Hello, everybody. Really appreciate your time spent on this webinar with me. So I will slowly go through the presentation to discuss which things are very important to all of us. Why photodiode testing matters to improve the reliability of the end product. So what I will do, I will quickly maybe introduce myself here to you guys. Okay, I'm a founder of semiconductor reliability testing company, and basically over the last 30 years of experience was in the field of electronic design and system design for automated processes. That included a semiconductor industry, but as well others, and I will discuss that a little bit further. So basically, over my past 30 years, I got granted patents in solar concentrator and energy management technologies. And as you can see it here on the picture, this is solar concentrated technology. And this is energy management equipment which we design for reducing energy costs for industrial and commercial applications like grocery chains and anything about 50,000 square feet or meters. We were doing this. And since 2016, I developed a cost-effective modular automatic test equipment for laser diode and photodiode applications. And this system was compatible with a wide range of environmental chambers. That is very important. So you have a flexibility to use sub-zero testing or humidity or high temperature or vibration, depends on your needs. However, the system is flexible to deal with these different stress conditions, and this is what I have done. And for your information, our ATEs are built for flexibility with swappable fixtures and mounts for testing various photodiodes packages. Just imagine you are testing a TO-CAN today, and tomorrow you want to test a butterfly package. So our system is intact, except you are swapping the fixture to do the new test. And incidentally, just for your information, this is a typical control system of our ATEs. This is where the brain processing power is happening and controls and data storage. So now that being said, I will take you to the next page. Why photodiode testing matters for defense safety? Well, as you may know, laser warning receivers and failure to detect incoming laser threatens any vehicle, and it compromises the whole action. So that's very important. In laser target designation and seeker guidance, photodiodes must operate flawlessly under shock, vibration, and extreme temperatures. And for your information, our ATEs have the flexibility to validate photodiodes under simulated stress environments. That includes humidity, temperature cycling, vibration, accelerated temperature, and to ensure basically that the system operates optimum and provides safety to the crews. And we help defense contractors or OEMs mitigate field failure risk through accelerating aging and real-world scenario simulation. So it depends on what you need. We can actually provide you a package which will provide the solution. And here what we've got is photodiode package types supported by our ATE systems. So as you can see it in green, the defense, we can provide C-mount, butterfly, TO-CAN, C-mount package interface. And for telecom, TO-CAN, butterfly, card edge systems. So depends on your needs. We provide custom built PCB interface so we can take physically your your package photodiodes, and we provide interface so we can actually read the values during the test. Here is the next slide, which deals with why photodiode testing matters OEM fabs and telecom manufacturers. Well, high speed it's a key right now, whether it's QSFP or other models on ultra fast photodiodes to ensure accurate optical signal detection in telecom networks. So to ensure signal integrity and long-term performance, our system validates photodiodes under stress conditions, and this is what we really excel. For example, here we have a dark current test under elevated temperatures that will actually ensure that your photodiode is going to perform for years to come. IV test for this diode, fit test to see failure in time and see how many years that device can really last based on your current technological information provided during the manufacturing process. And obviously bias voltage test. As you know, diodes can only handle certain voltage levels, and our systems depends on the type and request. Can go up to 200 volts of bias voltage. Well, next slide deals with photodiode testing in Telcordia GR468 core. Why it matters? Well, bottom line is it's a tool. You can actually use it. And under accelerated aging testing, it is designed for worst case evaluation and is stricter than some even commercial or mill standards. Especially in critical, it is critical for telecom networks requiring 25 plus years of reliable service. So what Telcordia platform or tool can do for you? Well, it can validate performance of your photodiodes, can guarantee reliability, because once you go from accelerated aging and so forth, the system will detect early failures under various stress conditions. Well, it's going to predict a lifespan. What's cool about Telcordia GR has a tabulated values, and you will be able to use for photodiode sort of constants to calculate your lifespan of your systems. Definitely, it's going to help you to improve production yields because it's going to identify the issues of your photodiode. And we had an incident that we had two types of suppliers of a photodetector, and one actually was failing much earlier, although the supplier was convinced that it's going to be equal to the one which they wanted to use as a reference. But bottom line is you can see the defect, you may see the defects, and you can optimize manufacturing process. Well, ensure system compatibility. So basically, if you are looking for signal to noise ratio, this will help you with this. And so what does Telcordia GR468 core offers? What are key areas it covers? Okay, it's basically, it provides the following. It covers device qualification. Under that, procedures to qualify new devices before deployment, environmental and mechanical stress testing. Under environmental testing, what is included? Temperature cycling, damp heat testing, high temperature operating life. Under mechanical, you have testing of vibration, shock, hermeticity, obviously for sealed devices. Under burn-in and screening, it provides procedures to weed out early life failures, often includes elevated temperature and current stress and in some application. Reliability monitoring, ongoing testing and statistical analysis, and failure rate determination, for example, fit. Reliability testing. Well, GR468 allows use Arrhenius acceleration models to extrapolate test results, and you can actually have a tabulating information to plug in the information in your test. And it is actually GR468 is perfect for accelerated aging testing. It's designed for worst case evaluation. So that's very important tool to consider in your applications. Well, let's talk a little bit about the software consideration. This is the example of our software. Number one is user interface and reporting. Our system is intuitive for real-time testing and functional reporting. So you don't have to really scramble in a manual to find the certain aspect of the testing. It is intuitive GUI. Test configuration, it supports multiple test scenarios without complex programming. So everything is done for us. Measurement capabilities, like in this case, you have IV curve generation, dark current operation under elevated temperatures, and that as well includes the issue of your bias voltage. You can actually adjust your bias voltage and see what happens. And so you have that flexibility to test your product thoroughly. And obviously failure detection. So during the test, if there are failures of some of photodiodes, the system will notify you which failed and what time and so forth. So you can actually collect this data and process it further. Here what we've got is an example of a configuration screen of our software. On the left-hand side, you can actually select what you want to test. For example, in this case, fit test was enabled, turns green. So on this case, in this case, you had a fit, but later on you can have an IV sweep. You just click on this button and it's going to do a function of the IV test. Here in the middle, you have a general configuration setting, number of samples. Let's say you wanted to test 8, and you are reading interval every 1 minute. You can change it to any minutes you want. Typically, we recommend every 60 minutes to test it. A runtime test, in this case, was chosen 2, but you can go 8,000 hours, 24,000 hours. It's a variable you can choose. And under fit configuration, if you decide to use GR468 Telcordia, you can actually indicate stress test temperature, let's say 175 degrees C, and normal operating temperature 40 degrees. And according to Telcordia spec for photodiodes, for example, you choose 0.7 activation energy. On the right-hand side, you choose fixed bias voltage at what voltage you want to test. Right now it shows 200, but you can put 9 volts, 6 volts, whatever number you can go up to 200 volts. And if you are testing, doing IV test, you can have a sweep target. So the maximum voltage in this case, it shows 200, but you can have it set at 9 volts or 6 volts. And sweep increment, instead of, right now it shows 4 volts, but you can set it to 1 volt, 0.1 volt. And sweep start, and right now it shows 1 volt, but you can set it any other value. So that's a configuration. Now I'm going to take you to fit enable screen, okay? So what we see it here on the upper left hand side is a reference information. So you will put your reference test number, the sample reference, description, tested by. Once that is filled, you are pretty much ready to start the test because you've done your configuration, you selected number of samples to be tested, and you just press the button start. And the system starts testing each component as you specify. As you can see, current is being read here, and bias voltage is here, case temperature is indicated over here in this column. So that is being said about the fit test. And in addition, as you can see, the fit test button is lit green to indicating that you are doing the right thing. Here it is a IV test screen, and as you can see in the upper corner, you fill out that section, and you are pretty much ready to start when you press the button start button, and you specify number of components, and let's say you had 2 components. Right now the system is reading component number 2, and it starts filling in the data for IV test. So you are starting at 0 volts, 2, 4, 6, and according to that, the information is being sort of filled out for your current, dark current, based on the temperature you defined, whether it was 175 degrees or 150 or whatever you might have it. So that is being said about simplicity of using IV test. Say connection diagram. Let's go to the connection diagram and talk a little bit about this. It's very simple. As you can see, that's a photo of a 128 laser reliability system. And basically, we have a station here. You have your communication cable, which goes between your interface, printed circuit board interface, and your components into the environmental chamber. And as you it's a DB37 cable, and high temperature take cable is this part here, which can handle this high elevated temperature. And the system collects the data from your photodiodes, and the information is being stored here. So you have a monitor, you have a UPS system to ensure that you don't have any power failures during the test process. During the operation, the system is monitoring the power supply of your supply. And if for any reason you lose power here, and this is your basically circuit which monitors power failure, then UPS knows about it and automatically runs the test, finishes the test, whatever you needed to do, collects the data, stores it. So when the power failure comes back, you know where you left things off, and you didn't lose 8,000 of hours of your testing. So you have a monitor, obviously, you have a keyboard and mouse, so you navigate as we were talking briefly a couple slides above. Custom DUT interface boards. I touched briefly on this before, but I would just go through this. So basically, this is one of a butterflies, a 7-pin butterflies, but you can have a 14-pin butterflies. On the left-hand side, we have a combo system, a laser diode and photodetector as a one. So a laser part is doing its job, and we are monitoring basically the current, dark current of these lasers. We are reading the laser values. So very important part is here that you know that we are compatible with the telecom, C-mount, butterfly, or card edge connectors, or any other configuration which you require, and we didn't mention it here. Very important is that designated temperature of these printed circuit boards is up to 175 degrees. So we chose the material which can handle this high temperature testing without impacting the performance of data collection. Okay, hardware and data handling consideration. Well, I will repeat a little bit again. Basically, our custom PC board interface for devices under test, TUTs, include TO cans, C-mount, butterfly packages, or card edge connectors. PCB interfaces are upgradable for future DUC packages. That's very important. As I mentioned sometime in the ago, that you can upgrade your system from one TO package to the other without changing anything else except the interface, PCB interface board. And basically, all of this is compatible with environmental test chambers. So that's very important. So if you have a test chambers and you don't need one from us, you can use yours as long as it meets these requirements. So that's very important for somebody who wants to consider some cost reduction. Data handling, CSV data collection, all of this is collecting CSV the format, so you can export it to Excel and you can process it the way you want it. And basically, the system gives you all this data for failure in time or mean time to failure calculations as well. If you want to use your calculations and deviate from what we provide as a standard, you can actually use that as an option. Highlights in overview. Flexible, basically the system is flexible test configuration, no programming required, GUI-driven interface, so it's very simple to navigate. Power operates between 110 and 230 volts, depends on location, 50 and 60 hertz. Data logging CSV files, fixture customization, we provide that, custom DUT fixtures available. Support and training, as long as we have internet connected to the system, we can provide remote diagnostic and support and onboard training. So the strength is in customer support, like with anything else. So during a test, if you require additional help, we can actually help you immediately by logging on to the system and navigating through what is not clear, and we can help you anytime. And wide environmental test range, basically the system can work, depends on a chamber chosen, from -40 degrees C to 175 degrees C. And then you can have your humidity included, and that gives you the complete package and flexibility to switch from one project to the other. Here are examples of some specifications. Basically, input voltage depends whether you are US or you are in Australia. You'll be 120 or 240 volts. Power consumption for this application is 250 watts. Bias voltage 0 to 64 volts. But as I mentioned, in application when you need 200 volts, we can provide that. And the reading range is from 100 nanoamps to 1 million nanoamps. And so you can actually specify what you're looking for. And the number of reading samples per station is 64. So each station handles 64 of photodiodes, but you can stack it whether you want 124, 256, or 1000 and change. So that's important that you can have a modules and you can stack them. So you can start with 64 diode testing, but later on you can add another module and it gives you another 64 testing laser diodes opportunities. So material is steel, and the weight roughly is 80 kilograms a pop. Thank you guys for everything, and looking forward to talking to you later. Have a good day. Bye-bye.